Good morning, good afternoon, everyone. My name's Nick Warburton from Global Distribution. Thank you very much for taking the time out of your day to attend our Building Hyper-Resilient Software-Defined Storage Solutions in partnership with DataCore, ATTO Technology, and Western Digital. As I said, my name's Nick Warburton. I'm Director here at Global. Also joining us on this webinar is Craig, who's the Business Development Manager for Northern Europe for DataCore, and Eric, who's one of the leading customer engineers at ATTO Technology, and also Kagate, who is the Business Development Manager for Western Digital, and he'll be talking about some of the platform products that they have to offer. So this is the third, so as some of you know, this is the third webinar in our series of bridging the IT gap. The two previous webinars, just to recap, are already live on BrightTalk, so they can be rewatched as this one can at your convenience. So just to recap, the first webinar on the 19th, we talked about how ATTO Technology XtreamCORE intelligent bridges allow customers to disaggregate storage from compute resources. And effectively, this paves the way for new architecture and workflow possibilities to lower the total cost of ownership of these software-defined storage applications. And the XtreamCORE allows new storage architectures to be developed by DataCore for their SAN Symphony products, VMware vSAN, and other software-defined storage applications. We also talked about how XtreamCORE can bring network connectivity, either Ethernet or Fibre channel, to SAS tape libraries from Dell, HPE, Quantum, and Spectral Logic, for example. And finally, in that webinar, we talked about how the XtreamCORE could allow for expanding the capabilities of Blade servers by connecting external SAS devices such as JBODs and RAID arrays tape libraries to Blade servers. The next webinar, the second one on the 1st of September, was more of a technical deep dive, technical overview of the XtreamCORE, hosted by Matt Mercurio, one of the application engineers at ATTO Technology. So if you're interested in getting into kind of nuts and bolts of the XtreamCORE, we're not going to go into that in this webinar, but it's available on the previous webinar. And then today, we're going to be talking about building these hyper-resilient software-defined storage solutions. So this webinar, we're focusing on DataCore, and we're really pleased, as I said, to have Craig with us today. Specifically, he's going to talk about SAN Symphony, and we're going to see how ATTO XtreamCORE can help build storage architectures for this, help bring new solutions to life. And then we'll see what value that WD or West Digital platforms can add to the solution overall by lowering the total cost of ownership, both in the cost-effective nature of their platform, but also their value add in terms of the resilience of their drives and their platforms that can reduce kind of failures and returns significantly over their competition. So let's just have a quick snapshot for those people that aren't too aware of the various companies. DataCore have been in business for 20+ years developing software-defined solutions. One of the staggering facts about the company is they have over a 90+% customer satisfaction results in surveys, and 95% of their customers renew with them. They have 30,000 installs around the globe. ATTO, for you who are not familiar with them, they're a connectivity leader, been in the industry for 30 years, and they're trusted by the likes of NetApp and Dell, HPE, etc., for integrating solutions into those companies' product lines. And then probably Western Digital will be familiar to all. They're at the forefront of game-changing innovation, from sort of first hard drives to first helium-filled, helio-sealed hard drives, and more recently 3D NAND flash. They have a staggering 14,000 active patents, which puts them, I think, in the top 3 or 4 worldwide. And in a presentation, we're going to talk a little bit about their Data 60 and Data 120 hybrid storage platforms. So just before I hand over to Craig, I'm just going to show you a quick overview of the solution that we're proposing today. As you can see, you have your servers, either virtual, VMware, Citrix, your applications running, which are connected over Fibre Channel or iSCSI to the DataCore servers. The really interesting part of this is the ATTO XtreamCORE as part of this presentation, which, as you can see, disaggregates or disconnects the DataCore servers from the JBODs. And this is what Eric, in his part of the presentation, is really going to go into it, and you'll see why this is sort of such a game-changing architecture design. We are going to be taking some questions at the end of this presentation. Below the presentation, you have a chat box, so please do send in your questions during the presentation, and we'll do a short Q&A at the end. But now, without sort of too much further ado from me, I'd like to ask Craig to take you through the key features of SAN Symphony and tell you a little bit about DataCore. Craig, thank you for joining us, and over to you.
Well, thanks, Nick. Yeah, thank you everybody for joining. Yes, as Nick mentioned, my name's Craig Atter. I'm the Business Development Manager for Northern Europe for DataCore. So what I want to do is just start with giving you a little bit of background on DataCore and what we do. As Nick kindly outlined, you know, we've been around for 22 years now, so a long time. Doing what originally started out as storage virtualization, and which is now morphed into what we all know as software-defined storage. And really, you know, if you think about what's happening with technology, you know, every 3 or 5 years with refresh cycles, technology's changing, people are looking for bigger, better, faster, or extending the life of existing, and part of that problem is that every time you want to move to a newer technology, maybe a different vendor, that leads to a lot of complexity in how you manage it. You know, how do you ensure, you know, your operational continuity as your hardware ages and you try to replace it? You know, how do you migrate the data without disruption, sidestep points of failure, you know, pool capacity, things like that, manage those different brands. And so software-defined storage, you know, separates the hardware from the software. So whereas before you had those storage silos, now you can take a solution like DataCore and wrap it around those different vendors' solutions, virtualize that, and present it back to the hypervisor. So in that sense, you can help expand the life and look at providing a consistent set of services to the customers. So, you know, software defined is the way it is. If you think about the evolution of technology, just to show the proof of this, you know, over the last 10 years, everything has become software driven. So from bare metal to virtualization with the likes of VMware and Hyper-V, to cloud adoption with Azure and AWS, through to now storage with software defined, and maybe networking next. So, you know, cloud is obviously an instance of that evolution, but at the end of the day, change is inevitable. And it's not a matter of if, but when and how. And that's really what DataCore can help with. So that software-defined approach, you know, that separation of the hardware from the software, as you can see in this diagram, by inserting DataCore in that data path, it doesn't matter whether your data is on primary high-performance spinning disk, or whether it's on, you know, lower performing storage, and it doesn't matter which vendor it's from. We're vendor agnostic. You can wrap yourself around all of that storage to help with your scale up, scale out capabilities. You know, so what you end up with is this device independent control plane. It operates across the storage systems, you know, and gives you that consolidated set of functions. You know, the way vendor A does snapshots is different to the way vendor B does snapshots, which is different to the way vendor C does it. So rather than having to learn multiple different vendors, interfaces, and applications, by using DataCore and software defined, we can wrap ourselves around all of those different vendors and deliver a consistent set of services to those users. So now you're only learning one management interface, one way of doing, snapshots or tiering or replication. And at the same time, we've grown up providing high performance, high availability solutions. So how do we achieve that? Well, DataCore has two products in its portfolio. We have the SAN Symphony product, which is our heritage, which we've been doing for the majority of those 22 years. That's our block-based storage virtualization solution. And then we have a new product that we launched last year, which is called vFILO, which is file and object-based. So obviously today we're going to talk about SANsymphony and the block storage solution, but we do actually cover block, file and object within the portfolio. So a little bit more about SANsymphony. So as I said, this is based around block storage virtualization. So this is the ability, regardless of whether it's primary or secondary storage, and whether that's, latest NVMe or SSD through to traditional spinning disk, it doesn't matter. Basically, we can virtualize any internal, external, direct attach, iSCSI, Fibre, doesn't make any difference, storage, virtualize it, present it back to, as I say, the hypervisor or the OS or the database, and then what that means is it gives you that single interface to scale up, scale out. And in terms of additional components to that, we now have something called DataCore Insight Services, which is a SaaS solution that sits on top of SANsymphony, and this uses artificial intelligence and machine learning to give you predictive analytics insights into your data. So, using a traffic light type system, red, amber, green, you can get easily accessible information around what's happening within your environment that DataCore's managing. So how do you deploy DataCore? As we sort of mentioned earlier, this diagram, you can see that DataCore sits in the data path. So what you do is effectively you will have either your hypervisor in this sense, so your VMs. We can either sit as a separate storage function, so we can sit in your traditional sort of server SAN type scenario, or we can be deployed as a VM in a hyper-converged environment. And what you do is effectively it sits in the data path. We wrap ourselves around that storage, as we've spoken about. We virtualize it, and then we present that back to the hypervisor. You can start with a minimum of one node, but that doesn't give you the high availability and the resilience. And one thing to notice with DataCore over and above a lot of the other vendors in this space is that we only need 2 nodes to provide high availability. So a lot of the others need 3 nodes, and that's because we work as a grid architecture rather than as a cluster. So both nodes are active in all the time. So this is just a typical deployment. As I say, delivering on that scalability, you can then seamlessly add in, migrate, move. You can also bring in existing infrastructure. So if you wanted to move to a software-defined storage solution, you can deploy us alongside your existing infrastructure. We can effectively integrate that storage, replicate it into the DataCore environment, so you can then seamlessly migrate the data off and decommission your historical, or we can then use it as a tier of storage within the DataCore environment to help extend the life. But that's DataCore in summary. This is a screenshot of the Insight services that we spoke about, and what that means is, as you can see here, you've got your traffic light type predictive analytics. So this could be something like a snapshot has failed, click here to delete the old snapshot and resnap, to you've got plenty of capacity and you haven't turned on a feature like CDP, which is something called our snapshot like example, I guess, is Sky Plus. It's the ability to roll back your data up to the second, up to 14 days in the past, so continuous data protection, which is great for something like a ransomware attack. So we've got a lot of NHS customers who use this technology, and as a lot of you may know, they were targeted a couple of years ago, and those that had CDP turned on were able to roll back, recover to the point before encryption, patch the servers, and carry on. And then there's some sort of performance statistics on the right-hand side that we can use to give you some input. So on that note, that's just a very quick high-level introduction to DataCore. I'm going to pass over to Atto now and to Eric, who will tell you more about the XtreamCORE.
Great, thanks very much, Craig. Just a quick reminder that we are doing the Q&A at the end of the session. We've had a question already, so keep them coming in. But Eric, yeah, if you could take over and tell us a little bit more how the XtreamCORE Intelligent Bridge adds to that kind of workflow from DataCore.
All right, thank you very much, and good morning, everybody. I am on this side of the ocean, so it is early in the morning for me. If you've attended the other presentations and you have a base understanding of what the XtreamCORE Intelligent Bridges do, we will basically take anything block storage SAS, be it a RAID array, a JBOD, a shelf of flash disks, and change its transport protocol to either Fibre channel or iSCSI. What that's going to do is give a lot more design options for packages such as DataCore to add a level of resilience that they may or may not have had before. So when we talk about the changes that disaggregation can bring, and also what SANsymphony brings to the table, the first thing that people want to do is compare it to a RAID solution. You know, we've had RAID solutions for many, many years. People have always kind of felt that that was the thing to do. You've got a lot of vendor-related devices where that's their focus. But traditionally, you would put your hardware redundancy, your disk redundancy behind the server, behind a controller. And what that would do is kind of hide those disks and hide a lot of the properties of the disks from SANsymphony. You would basically try and RAID the individual disks, RAID 5, RAID 6, 50, 60, and then you would use SANsymphony to either mirror volumes to other volumes on other RAID arrays, which is where they really specialized in being able to take multiple vendors' hardware and be able to replicate between the different arrays. However, RAID arrays now with the disk size are very, very slow. Trying to rebuild a RAID array that's based off of 12, 14, 18 terabyte disks can take days. And that's something that just isn't as acceptable as it used to be. So for SANsymphony, the fastest solution that they can offer involves JBODs. JBODs involve mirroring of disks, mirroring of virtual disk and disk pools. If you're familiar with their software, then you understand how they work. I'm not going to reinvent their wheel, but JBODs basically allow the server to directly manipulate the drives, which is what SANsymphony specializes at. So when we talk about a traditional design here, we would have either a SANsymphony server with internal disks or a JBOD or a RAID array hanging off the back end. They would be connected through a heartbeat so that they could synchronize their data together, but ultimately it's all about mirroring information between the SANsymphony nodes. What we brought to the table when we disaggregated was the ability to create an environment that we started calling DAS over Fibre channel. So because of one of the features within our bridging products, and it's called host group mapping, it allows us to create not your traditional Fibre channel initiator to Fibre channel target zoning, but we can go from the fiber channel initiator all the way back to the individual disk. So we can tell a server that these disks belong exclusively to you, but we're extending the distance. So it's as if we pulled the disks out of the server, extended to whatever distance makes sense, and still gave that exclusive access to the server through a single interface. And this created that DAS over fiber channel. It allows servers to have control of the disk without having to have a shared file system. Without having to share the disks, pretty much anybody can take advantage of those disks. There's no limits to what can be done. The nice thing is that it adds that versatility of multipathing and multiple SAS controllers when you're using multi-controller JBODs and multiple paths. So please don't ever design with a single point of failure like this. But with that said, this is just to illustrate that we can connect VMware servers, DataCore servers, Windows servers, Linux servers through fiber channel to multiple SAS JBODs with very, very low latency. We're getting 4 microseconds of latency coming through us. And this is how we disaggregate the storage so that we can determine which individual drives through our appliance are going to go to which individual server. So, as I said, direct disk management is the fastest and cleanest way for DataCore to handle things. The RAID volumes hide information. We don't get that individual disk management ability within the SAN Symphony servers. And the nice thing, and nobody really wants to talk about what do we do in the event of a failure, but we have the ability with the host group mapping to reassign all the disaggregated disks from one server to another. And it literally takes seconds. So when a software-defined server goes down, you're running in pairs, you take a little bit of a performance hit because instead of 2 servers serving up your storage, you're now down to 1. Possibly your redundancy is affected as well. You may not have as much storage redundancy. So what we can do is allow that redundancy to be reimagined. Again, this is a single point of failure design, but it's a lot less risky because the only single point of failure when you're using a single large JBOD is the backplane of the JBOD itself. Those traditionally have mean time between failures measured in the several hundred thousands of hours. So it makes a very, very good design for it. But traditionally, you could not design this way before. You could not take 2 SAN Symphony servers and share a single JBOD without having to have something managing the reserve, the release, managing who can see what drives. This would be your typical design. And this would be similar to the way it was done before. However, we can take it a step further. Now we can break up the JBODs and help that single point of failure or help that resiliency get even better. You can already see that we've got multiple fiber channel pathways going to the data. We also have multiple SAS pathways going to each SAS disk. You could have a single DataCore server, or if you really, really want to push the envelope, you can take large JBODs and break them up so that individual drives are mirrored within or to other nodes. So we're back to the main design. But what happens if one of those nodes goes down? Traditionally, that storage would be lost. That capacity would be lost. And like I said, there's a little bit of a performance hit as well. However, by being able to repoint all those disaggregated drives to a new DataCore server, one that we could spin up virtually, we can have that data protection back up and running in as little as 15 minutes. So the performance and the data is back to what it was before. That is, besides the resiliency, that little extra oomph that ATTO is bringing to a DataCore solution. And now I will turn it over to Western Digital.
Great. Thank you so much, Eric. That was really interesting. Just a note, again, we are doing some questions and answers. There are a couple in. I'm sure there are many more. It's only a text boxed away, so please do send them in. And again, so now it's my pleasure to introduce Kegate from Western Digital. He's been somewhat parachuted in to us at the last minute, replacing a different speaker. So hopefully he's been able to join us. So Kegate, over to you.
Hi, Nick. Hi, everyone. Am I audible?
Yes, you're audible. You're good to go.
Okay. So my colleague is enjoying the wedding of his son. So I gave him the the free slot and then volunteered for the stack. So hi everyone. My name is Çağatay Kilic, and I'm around since 1994. So maybe my audio doesn't look like, but I'm now kind of belonging to the aging IT guys group. Today we will be talking about the Western Digital, the solutions of the Western Digital, but I just want to join my four speakers. I'm a personal user of an ATTO device. The 7500 is in our lab. I quite enjoy the latency. It's a brilliant product, as well the DataCore solution. So I'll also kind of share with my kind of live and lab experiment here. So here we are, Western Digital. In Western Digital, we call ourselves the company of innovation. A lot of technologies which are belonging to their day in, day out IT life has been pioneered, developed, invented by Western Digital, and going forward. And the latest one, which we launched last year before COVID side, has been the zone storage. We are investing heavily on the future of the disaggregated data center with the Fabric devices, and yeah, the game is not over. It's a long race, and it goes on. One of our advantages versus some of our competitors, like whatever we build, we are vertically integrated, which means everything, well, not the plastic and the boxing, but everything which belongs to the core technologies of the product, we own them. So if it is head, media, wafers, motors, we don't do, honestly. We don't do, but there is like one big major guy who builds all the spindle motors for the hard drives. But the rest, all the critical technologies we build on ourselves. Gives us the assurance of the quality from the manufacturing side. Similarly, on the flash products as well, we do the same. We are one of the 4.5, maybe 5 manufacturers of NAND flash worldwide, and which gives us the assurance again, like what we build, we know what is inside. And especially NAND being a kind of relatively new technology versus the hard drives, which are like 40+ years around. It's not like every NAND is identical, and if you know your NAND, you can build the appropriate controlling technology on top of that. Gives you a lot of headroom in terms of the reliability, in terms of the appreciation of the NAND, and so forth and so on. With that, I think we may claim like we have the diverse, broadest storage product portfolio, coming from the smallest NAND flash-based USB sticks, SD cards, into multiple petabytes of JBODs and then servers. The one in the circle is my division, so what we call is the enterprise product group. And even on the core, which are like today's topic relevant, is the JBODs, JBOFs, basically the drives, we call it like the drives which are packed in a metal box instead of a carton box, right? So as of now, we are the leader of the capacity race for hard drive companies. There has been a traditional race, like, who is building the highest capacity. But it's not only building the highest capacity of the product with the highest reliability and the lowest returns. and we are leading the race at this moment, but it's a long race, as I said. The leader might change, but for the time being, we are in the front row. We recently launched our 18 terabyte CMR and 20 terabyte SMR devices. Going forward, SMR is going to gain more and more room because the data gets bigger. The bigger the data, the more sequential it is, and SMR can really profit a lot from big and sequential data versus small and random data. That's more of a kind of transition in the first space going to happen on the cloud and gradually come back into the client, consumer, and server level. Similarly, we also have on the enterprise group the NAND flash-based SSDs. NVMe is our bet. We continue until the end of next year our SAS product lines, and SATA on the enterprise we actually quit last year, early last year, because the interface is pretty much limited, despite that you could get much more out of the flash-based product. Similarly, which is also happening to SAS, because SAS itself is 12 gigabit, a bunch of SAS devices already saturate one pad. So becomes going forward. I mean, today it's still a valid technology for the coming 2-3 years, but for the long future, we see like the NVMe is going to be the winner of the race, and that's why we put all our efforts there. We have the lowest latency products with the dual ports, the high-end NVMe's, which goes up to 1.2 million IOPS and then almost 7 gigabytes a second. And then we have the mainstream line, which is 500,000 IOPS. Of course, the higher number is the read, and between 0.8 to 2 dry writes per day. Well, now the core topic of today, how you combine these three major pillars of DataCore, ATTO, and then Western Digital. DataCore does a great job of softwareizing. I don't know if this word exists in English, but the fiber channel-based storage, right? And ATTO fits there perfectly because it gives an extreme low latency for on a block level device. So if you plug our JBOD into an ATTO device, on the other hand, you see all the individual drives as if they are a native fiber channel devices, extreme low latency. And well, sometimes I hear like, yes, but the box doesn't do any RAID like these other storage enclosures. Well, it's software defined. You don't need it, right? And RAID itself has a long history. It came all the way long, but it has own limitations. If the mankind is really growing the data like we do in the last couple of years, right? RAID itself is not a solution, but a part of the problem. The amount of the devices you can RAID is limited, and earlier mentioned, with today's capacities, try to rebuild an array of 18 terabytes. The system is downgraded mode almost a half a month, if not any longer. So the beauty of this solution is like on the higher tier, you use the NVMe's, the cards, which gives you the first tier extreme fast low latency storage. Then you can use for the virtual pools and then virtual machines the SAS SATA based the JBOFs, which is also another certified solution of ours with DataCore. Well, then the final layer is like, okay, I have JBOD, a bunch of drives, I need a lot of capacity, and because the replication is a much easier solution with no downtime, and then plugging an ATTO in between makes this solution very low latency, extreme high reliability, and high available, successful. Right. So how does our metal differentiates than the others, right? Well, since we have a long history of we know how to build drives, and we know like what the drives are really sensitive to, we integrate on our bare metal, basically JBODs, because they are more designed for the mechanical drives. We have some patented technologies. One of them is a flexible backplane. What we call is the ISO vibe. basically comes from like isolating the vibration, especially in high density enclosures with so many drives sitting next to each other, you know, shoulder on shoulder. If one of them is really angry and rotating and doing some seeks, that really disturbs the neighborhood. And actually, even with the backplane, that disturbance is spread around the larger population of the drives, and it all gets disturbed. So the backplane is sliced from, it's like a square, but sliced from 3 sides, which allows the spindle drives to vibrate on their spot. It has a soft mount. There is no screw. Everything is toolless, and then the 2 pins on the carrier just slides into 2 rubber holes, which leaves some room for the drive to dissipate this nasty bad energy generated, and then keep the neighbor drives still cool and calm. Another one is like in such kind of high density solutions, the circulation of an air, cold air, what you have in your data center, becomes an issue. And we add additional cooling layers, which absorbs the cold aisle, cool air, and then redistributes from the middle towards backwards towards the hot aisle of the chassis of the cabinet of the data center. With that, we have a very nice increase on reliability, which I'm gonna show in numbers in a minute. And all our devices are toolless, which means you don't need a screwdriver, you don't need anything. Actually, even the top cover of the J-boats, they stay on the rack. So basically you pull your enclosure, you access immediately to all the components that you might need to do the maintenance. Well, that's another thing which most of our customers really like on our devices. Like, the only components you might need to maintain are the back blowers, the back fans. Besides that, everything is in a front-hand maintenance without any tool, and it's very easy, including the I/O modules, including the drives, including all kind of fans. It's a very easy maintenance design. Right. These are the individual diagrams of like how and where the component sits and how easy they are to do the maintenance, right? The only thing you need to bring is like your 2 fingers. You don't need any tools. Okay, these are the hot aisle service. The only component, as I mentioned, are these orange looking blowers, the external blowers. These needs a backside or a hot aisle maintenance. The rest is an easy catwalk from the front side, right? Okay, so my colleague likes putting a lot of arrows here. So this data is some future looking because we are just in the mid of the evaluation cycle. Our products all come in with 5 years bring-in warranty, and the 2 technologies which I mentioned earlier, the IsoVibe, the vibration isolation, which doesn't only improve the performance because you avoid doing more spindles until your head is repositioned on top of the track. As well, the Arctic cooling improves the reliability, and we are tracking that number. We projected up to a 62% reduction in the drive return over the 5 years of service, and we are in the mid of evaluating these periods with these 2 technologies launched. We just passed 1,000 days, and it just grows nicely, like 2.5-ish times lower return rates versus our peers who are using some other enclosures. Right. How does our J-Bot look like? We have 2 flavors. One of them is a 60 bay, and which can accommodate up to 24 SSDs if needed. That's why they are the hybrid storage platforms. Today they start with a 96 terabyte population versus 840. Actually, after installing the 18 terabyte drives, it goes to, well, it just skips too fast. Okay, 1080. And the 102 bay, it's a little bit of a larger chassis. It goes 1 meter 20. So not every rack is very data 102 compatible, but that device used to go as high as 1.4 petabyte. Now we are actually passing 2 petabyte with the 18 terabyte drives, which we launched actually a few weeks ago, right? And if we are using an SMR, yeah, we are passing even the 2 terabyte barrier. Are there any customers using SMR? Yes, clouds already started to use, especially box-like applications where the random writes are very minor and the data is on a big chunks. SMR can really profit from that. And the next capacity point on SMR is going to be probably towards the end of next year or early year after. It's going to be somewhere in the range of 25. So the gap between an SMR and CMR technology is really growing in a nice pace, that for the same amount of dollars, pounds, euros, whatever currency you're investing, at some point it's going to be like you would be able to acquire 25–30% more capacity being able to utilize. Who supports that? Actually, most of the very recent Linux kernels, they support that. The Microsoft world is lagging behind, but eventually it is going to be there.
Brilliant. Thank you so much for that. That was really interesting to see the sort of drive technology going forward, and I think specifically interesting around the the ISO Vibe technology, etc., that is, lowering return rates by up to 60%. So, for large installations, data centers, etc., that's going to be quite a considerable saving over the lifetime of a product. But I'm just going to head towards wrap up before we just answer a couple of those questions that have come in. So if you've still got time just to drop a quick question over, we've got a couple to answer. I just want to recap really on the solution benefits. So by combining, DataCore, ATTO, and Western Digital, ATTO and DataCore reckon that we're, a 50+% saving over achieving kind of high availability versus kind of enterprise brands such as kind of NetApp, for example. Using the solutions together, we can create a direct attached storage environment over Fibre channel that provides a highly resilient storage solution with zero downtime. And then, as Eric mentioned earlier in his part of the presentation, that ATTO and DataCore are working on providing a solution where we'll be able to swap out and rectify hardware outages in as little as 15 minutes. And then finally, from WD, we've seen that their hybrid storage platform with its 5-year warranty, a single point vendor for both the disks and the expansion chassis is pretty unique in the market with all their drive technology, etc., that goes into that, and that adds an awful lot of value for customers. So you can see how customers can now have unique storage product offerings with WD platform products, and you've got the advantage of the kind of 50+, way over 50+ years worth of product excellence between DataCore, ATTO, and WD. So without too much further ado, because I know we're kind of running on a little bit, I do just have a couple of questions that maybe we'll shoot through. So one of them actually is just picking up on some stuff that both WD and ATTO touched on. Maybe Eric, you would like just to comment on this. It's going back to that RAID versus mirror argument. Customer asking, is it really is there really that much performance penalty for RAID versus for mirror for the DataCore solution?
On the actual day-to-day reads and writes, very, very similar in response. A RAID controller tends to add a little more latency than a software-defined storage solution would. So DataCore is going to be inherently a little faster. We only add 4 microseconds through. The seek time on those Western Digital drives is very, very low. So overall, you're going to see a better response time overall in latency with the SAN Symphony solution than you would with pretty much any commercial RAID solution. It's really the rebuild times that everything really shows itself, because if you think about a RAID rebuilding, it's not just involving 1 or 2 drives, it's involving all the drives of that RAID group, because it has to not only keep those drives spinning to access and then recreate the data from the missing drive, it's also writing the data that it's pulling together and recreating to that missing drive. Whereas when you are rebuilding a second drive of a mirror, that's essentially a sequential write. And as Western Digital said, you know, everything's becoming optimized for large block sequential writes. And that is exactly how a mirror will rebuild. So it's going to be measured in hours to fill even an 18 terabyte drive, as opposed to days to rebuild a RAID 5 that involves an 18 terabyte drive.
Brilliant. Thanks so much. And a couple of questions actually come in, all the same for DataCore. Actually, it's a question around how the DataCore SAN Symphony is licensed, whether it's on a couple of people asked whether it's a terabyte or a server license. Craig, if you're with us, could you just have a quick overview of the licensing model?
Yeah, so we license it based on the capacity presented to DataCore. So that's not necessarily the raw capacity that's available. By a petabyte of spinning disk, and you might only present 100 terabytes to DataCore, and that is what you need to license. But that license needs to account for high availability. So today, where it's a high available design, if you need 100 terabytes in a highly available configuration, you will have effectively 2 copies of the data. So you would need a 200 terabyte license. No longer licensed on nodes, which is how it was done up until about 2 years ago. Question.
Brilliant. Okay, thanks so much. I think we better kind of a couple more questions, but I'm conscious of the time, so let's we'll just wrap that up. As I said, all these webinars are available on BrightTalk, so you can grab a cup of coffee and rewatch them at your leisure. Especially the early ones, if you missed them, on the XstreamCORE and technical overview of it. Here's just a quick recap of who you've been listening to. My name's Nick from Global Distribution, Craig from DataCore, Eric from ATTO, and Kagate from WD. Their contact details are on here. If you have any questions, please feel free to reach out to any of us to ask them. I'd just like to say thank you very much for their time, and thank you very much for your time. It's been a pleasure. Bye-bye.